Hi everyone, good evening to all. Now we are going to study about moment of inertia. So what kind of questions they will ask or how to solve them. So the very first thing what we have to understand here is what is moment of inertia. So to define moment of inertia, we must to specify reference axis. Like if there is a point mass, then moment of inertia of the point mass about a reference axis is product of mass and square of the distance, perpendicular distance. Just like if this is the axis, this is the mass and this is the distance, then the moment of inertia is mr square about this particular axis. So about different axes, the moment of inertia will be different. So moment of inertia depends on mass and radius. And if you take the unit, it is kg meter square. Now, what is the moment of inertia of system of point masses? Suppose there is a system of n number of masses like m1, m2, so on, mn, and this is the axis, like this is r1, this is r2, and this is rn. Then the moment of inertia will become I1 plus I2 plus so on, In. That is m1 r1 square plus m2 r2 square plus so on, mn rn square. So this is the total moment of inertia of the system. Now, the next thing is what is parallel and perpendicular axis theorem. One more thing also I will tell you. If there is an axis and the mass is on the axis, then the moment of inertia is 0. So the moment of inertia is 0 because the perpendicular distance is 0. Now comes it's all about what is parallel and perpendicular axis theorem. So when you consider parallel axis theorem for any rigid body, so there is one center of mass. Now, if there is an axis passing through center of mass and the moment of inertia is ICM and you take any other axis parallel to it, the moment of inertia about that unknown axis which is parallel to the axis passing through center is given by ICM plus mass of the body into square of the perpendicular distance between the two parallel axes. So they will ask one unknown axis, moment of inertia of the body about one unknown axis. Then you have to take one reference axis which must pass through the center of mass. Then you can apply this formula for any rigid body. Now, for a planar body, just like sheet, circular sheet or rectangular sheet or square sheet. So, if you imagine two perpendicular axes, any two perpendicular axes, you can take them as like moment of inertia about them Ix, Iy, then moment of inertia about z axis that is perpendicular to the plane of the body, that will become Ix plus Iy. This is called perpendicular axis theorem. Now, what are the next thing is to solve or to apply parallel axis theorem or perpendicular axis theorem, we must remember moment of inertia of few bodies. Like when you consider a circular ring or disc, so the moment of inertia. So ring means the moment of inertia is mr square and disk means that moment of inertia will become mr square by 2. Now, Similar way, when you consider diameter. So for the ring about the diameter, the moment of inertia is mr square by 2, and for disc also, sorry, for this ring about diameter, so this is mr square by 4. Also you remember that for a rod of mass m, length L, about an axis passing through its center and perpendicular to its length, the moment of inertia is ml square by 12. And about edge axis, you can apply parallel axis theorem, then it will come ml square by 3. And in case of cylinder, about its axis, the moment of inertia is I equal to mr square if it is hollow cylinder, I equal to mr square by 2 if it is solid cylinder. Similarly, for a sphere, the moment of inertia is 2 by 5 mr square if it is solid sphere, and the moment of inertia is 2 by 3 mr square if it is hollow sphere. So these are the basic formulas we need to remember. Usually they ask in the question, based on which they used to ask question: ring, disc, rod, cylinder and sphere. Hollow sphere or solid sphere, hollow cylinder or solid cylinder. So based on these things, how the question will be asked, let's see few examples. Like the very first thing is, calculate the moment of inertia with respect to rotational axis xx dash. So this is the axis about which when you consider, see, it is at 20 centimeter. That means this distance will become 80 centimeter. Now this distance will become 30 centimeter. Now the moment of inertia about xx dash will become m1 r1 square plus m2 r2 square, where m1 is 1 kg, r1 is 80 centimeter means 0.8 whole square, plus m2 is 4 kg, r2 is 30 centimeter means 0.3 whole square. Now similar way, here in the second case, I about xx dash equal to, so there are three masses. So that first one 4 kg, when you consider 4 into 3 square plus 2 into 2 square plus 3 into 4 square. So this way you can find the moment of inertia of system of n number of point masses. So you have to find the moment of inertia of each point mass separately and then just add them like a numbers. That is the way you can find the moment of inertia of the system of point masses. Now similar way, let us take one more question. See, a point particle of mass 1 is kept at 1 comma 1 comma 1. The moment of inertia of the particle about z axis will be. See here, this is x, this is y, this is z. Now the point is at a distance 1 comma 1, somewhere 1 comma 1 comma 1. That means now from the axis, what is the perpendicular distance? That is what you need to find out here. So here x coordinate is 1, y coordinate is 1, z coordinate is also 1. All are 1, 1, 1. Now like this, see here, when three axes, when you imagine, so here the point is there at 1, 1, 1. Now it is having perpendicular distance of 1 meter from each axis. From x also 1 meter, from z also 1 meter, from y also 1 meter. Then moment of inertia about z axis means m into z coordinate square only. So that means 1 into 1 square, that is 1 kg meter square. That is the moment of inertia of the given particle about the z axis. So that way you need to understand properly what is given, what is the position of particle, what is the reference axis, and then how can we find the perpendicular distance, then you can solve it. Now, the third question. Three identical uniform rods, each of length 1 meter and mass 2 kg are arranged to form an equilateral triangle. So, three rods formed to arrange together to form equilateral triangle. Now, the moment of inertia of the system about an axis passing through one corner and perpendicular like this. So, it is like perpendicular to the plane. Now, when you consider like the joint, so the joint where I have drawn the line, so the axis is perpendicular to both the rods, see it in the video, so that the axis is like passing through the edge and perpendicular to both the lengths. Then if you consider one rod moment of inertia I1, another rod moment of inertia I2, I1, I2 both are same, that is ml square by 3. Both are same. But the remaining one when you consider, see, the remaining one is here. Now the axis is like this and the rod is like this. Like this. So when you consider, see, here rod is there. So about the central, see the rod is like this and about the central axis, the moment of inertia is like this. See, imagine one axis. So this is the actual axis, this one, and this is the reference axis. Now this is the perpendicular distance, nothing but height of the triangle, where height of the triangle is root 3L by 2 for equilateral triangle. So that the moment of inertia of the third rod will become ml square by 12 plus because now this is ICM and this is unknown axis. We have to apply what? Parallel axis theorem. So ml square by 12 is about its center of mass plus m into r square. R means root 3 L by 2 whole square. So that if you solve this one, then 10 ml square by 12 will come. So if you add I1, I2, I3, then you will get the total moment of inertia of the system, where L you have to substitute as 1 meter and M you have to substitute as 2 kg. Now similarly, one more question. Find the moment of inertia of a solid sphere of mass 5 kg and radius 2 meter about an axis xx dash as shown in the figure. Now it is solid sphere, so that about the diameter when you consider, the moment of inertia is 2 by 5 mr square. About the center of mass. Now about the unknown axis, if you apply parallel axis theorem, ICM plus mass into what is the perpendicular distance between the two axes? R square. So that 2 by 5 mr square plus mr square, that will become 7 by 5 mr square. So this is how we find the moment of inertia using the parallel axis theorem for any object or for any combination of objects. Now one last and final question. Two thin uniform rings made of same material and of radii r and 4r are joined as shown. The mass of the smaller ring is m. Find the moment of inertia about an axis passing through the center of mass of system of rings and perpendicular to the plane. Now see here, here the mass of the smaller one is m. Then the mass of the bigger one will become 4m. No. Yes. Because mass depends on total length. So here length is 2 pi r. Here it is 4 times. That's why it is 4 times mass you can take. And the distance between them is r plus 4r. No. R, this is r, this is 4r. So r plus 4r, 5r. Now you have to find the position of center of mass first. Now center of mass, let's say suppose it is at a distance x from the small m. Then what is x will become? For a two particle system, the center of mass position means from small m means 4m into total distance by total mass m plus 4m. So that will become, so mm cancel, 5 cancel, 4r. So at x equal to 4r. So the center of mass will be like, so this is m, this is 4m. Now this is the edge. Now it is at a distance. How much? 4r. Then this will become how much? R. Now this is the position of center of mass. Now about this axis, we need to find the moment of inertia. See, now you take this central axis for the first ring. Now you take this one as central axis for the second one. Now this moment of inertia is how much it will become? mr square. Now this moment of inertia of the another ring will become 4m into 4r whole square. So that will become 16 mr square. Not 16, sorry, 64 mr square. Now about this unknown axis, if you want to find the moment of inertia, you have to apply parallel axis theorem. For the first ring, when you consider, the moment of inertia will become about the central axis mr square plus m into the distance is 4r whole square. Plus for the second ring, when you consider about the central axis 64 mr square plus 4m times the distance is r square. Now if you calculate everything together, this is 16. So that this will become 17 mr square plus this is 4, 68 mr square. So that altogether 75, 85 mr square. So this is the moment of inertia of the system, complete system. So you have to take step by step. You have to find the moment of inertia of each body and you have to add them separately. So that is the way you can solve the questions based on moment of inertia of a rigid body or moment of inertia of a point mass. Now similar kind of questions I have given as assignment. So please try to solve them so that you will get the idea like how to solve the numericals based on finding moment of inertia using parallel axis theorem or perpendicular axis theorem. So thank you all of you. Because before that, one final thing, this is important because in rotational motion or in rolling motion, everywhere moment of inertia will come. So if you don't know how to find moment of inertia, then you cannot solve the questions based on rotational motion or rolling motion. That's why you should know how to find moment of inertia of these regular bodies, about radius, about central axis or about tangent or about anything. Then only you can get the things. So like for every object like ring or disc, when you consider, there is one central axis and there is an axis parallel to its and perpendicular to the plane passing through it, or there is an axis like diameter, there is an axis parallel to diameter and passing through edge. Similar way for sphere also, there is one diameter and there is one edge axis, and similar way you can get the any such object and they can give for any axis. So you have to remember the basic formulas, then you have to apply the perpendicular axis theorem or parallel axis theorem. Just like I will tell you, if this is one disc, now about diameter we have to find moment of inertia means this is like x-axis, this is like y-axis. Now about z-axis it will become ix plus iy. But you take x-axis or y-axis, both are looking like diameter only. So that iz will become 2 times I diameter. Because here ix or iy, both are same like diameter. So that the moment of inertia about any diameter is half of the moment of inertia about the central axis. So that is what that is the way you can use perpendicular axis theorem. But whenever you want to use perpendicular axis theorem, then you have to choose both the x and y perpendicular axis within the plane of the planar object. Then only you can apply that theorem. So please practice all the questions. We'll continue in the next session. Thank you.